Hey, what's up everyone and welcome back to another video. So today we will be walking through 100 NumPy exercises. So we did this previously with Pandas, but decided let's run it back with a bunch more problems, this time with the NumPy library. So we're going to be working off of this repo seen right here. I'll also make sure to link it in the description. And the way that I recommend watching this video is that there are a lot of exercises, and I recommend trying a lot of these exercises on your own, pausing the video, and then when you want to see how I would approach the problem, resume the video and see my solution. I'll make sure to timestamp everything so that you can find exactly the problem that you're working on down in the YouTube description. But I think let's just get right into it. Gonna be a blast. So I'm gonna go ahead and fork this repo. And then I will copy this link. I will open up a terminal window. I will go into my code folder, and I'll go ahead and do a git clone and paste in that link. And now I can navigate into that repo, and I'll do a code to open up that. So that's a VS Code function, and then that opens up automatically the repo. So you should be able to read now what's on the screen. Again, links are in the description. I don't need to see the October 2024 release of Visual Studio Code. Let's go to maybe the README to start. Maybe not the README. Okay, cool. So there's some hints and stuff here. All right, cool. So let's start with this 100 NumPy exercises.ipynb file. I'm also, if you're working with Visual Studio Code, I'm going to do a Command-Shift-P. I'm going to select interpreter, and then I have one I just call YouTube. I'll install all my packages there. You don't need to have a virtual environment, but it's just kind of a good practice. Then I guess I'll try running initialize.py and see if that works. I'll use YouTube. Cool. Okay, so I might need to install some packages. To do that, I can go ahead and open up a terminal window. And we can see that I'm on my YouTube kernel or YouTube virtual environment. I will start by doing install. Actually, there's a requirements.txt file here. So good practice with anything here. It doesn't look like it has the library that I'm looking for, but we'll see if this works. I'll do a pip3 install -r requirements.txt, I think. I honestly don't think that we necessarily need these specific ones, and we might have issues with these versions. So I'm going to go ahead and do a pip3 install NumPy, pip3 install Pandas, pip3 install Jupyter, pip3 install Jupyter themes. I really don't know if we need all these libraries. pip3 install md.utils. Okay, everything installed successfully. We might just have some sort of Python incompatibility issue. Go back to 100 NumPy exercises. Let's see if we can run this initialize now. Looks like it worked. And now let's go ahead and start doing some problems. All right, problem 1, import the NumPy package under the name np. And I think one thing I will mention is that I recommend trying to do these problems without Copilot completions, because I feel like if I turned this on, it probably would automatically autocomplete a lot of these. So like we see that. I'll see if it would autocomplete multiple. Maybe it doesn't know to do that. But I just think that I'm going to not use Copilot chat, but I will keep the completions and stuff on. You do want to be able to see the NumPy, what we have access to. So if I type in np here, it is nice to see these autocompletes, so I'm going to leave those on. And this is just something you remember. You get some private type methods if you do __. And with most packages, you can do np.version. However, I don't know what it means exactly by the config. Is there also a np.config or something that I can? What do I have access to here? Maybe dict? I don't know if that's what it's looking for. So I'm going to do a hint real quick on this configuration one. Okay, I mean, it just basically gave me the answer, but okay, np.showConfig. I guess I probably could do a function call. Okay, so if you need the config, you can do it this way. I'm not actually sure where you would use the config, but that is how you do it. Okay, let's go null vector of size 10. So I'm guessing there might be a np.null. I'm trying to think, np.array or np.nan. It's in a function. A null vector of size 10. I mean, also, maybe it's just wanting me to do null vector equals np dot. I mean, easiest thing is you can start with an array of none. And I suppose I could multiply this by 10, but that's not the most. I could do this repeat 10 too. Is that what it's looking for? If we look at our null vector, I'm going to do a. Is that what it's wanting? I might have to do a hint here. And actually, let's just go back. Hint. Okay, we also can do answer n, so we can double check if our answers are correct. Might also just real quick look at the README. I wonder, is there a nice... That's actually kind of cool. I'm using Corto to look at this in actual... Okay, I'm going to just... I didn't know if there was a way to automatically check things. Go back here. I might need a hint here, if this is correct or not. Hint 3. Why is it not recognizing hint? Oh, np's. Oh, that's confusing. You can do np.zeros and then just do either. I think probably just 10 would work. Let's see what happens there. That would work. I feel I thought it was talking about nuns though, or actual nulls. So that definitely makes the sense. You also could shape this in different ways. You could do 10, 1 if you really wanted a certain shape or something. But I think np0 is 10 seems right to me. And I guess we can do, what was it, solution or answer n. So we could do real quick, run that, and then we will type in answer 3, np0 is 10. Okay, cool. We got that right. All right, moving right along. How to find the memory size of any array? Well, we could take our null vector and see the memory impact of that. I think starting with typing out the NumPy unit that you're using makes sense. And I think if we do mem, or maybe there's, let's see, np.mem. size. Let's do null vector dot size. Is there a mem size? Or size of? Is that 192 bytes? Let's see. I'm going to just check one more time. np.size memory. Size of object in memory in bytes. Okay, so this right here, we did null vector dot size of. That would give us in bytes the size. So that looks good to me. I think to double check, you could try like some smaller numpy array. So like we would expect if we made some sort of array called np.array, and let's just say it's a 1, and we made this like an int data type equals int 8. So that would mean 8 bits. Is it not? I got to do it with quotes. That'd be 8 bits or 1 byte. So this should be a much smaller array. I'm going to real quick do a.size of, just to kind of check to see if this seems like the right function. You always could Google it too. 113. Probably makes sense. I don't know what the standard size of, like just the overhead of setting up an NumPy array is. That looks good to me. I guess I can do a hint 4 real quick to see. Oh, item size, okay. We'll see if that gives us the same answer. 8. This is interesting. There's if you do item size times null vector, let's look at the solution. Okay, I'm curious what this will give us. Null vector dot size times null vector dot item size, because I bet you this will give us the same exact answer as what we just had. 80. Okay, this is the memory size specifically of the array itself, but I guess the overhead of the NumPy, like going back to what we just did with the a equals np dot array 1, and then we did data type equals int 8. Like this array size is just 8 bits, 1 byte. And so when we looked up the size of that, and this is, you're learning as you go by figuring out these built-ins. We see it's 113. Okay, so the actual memory impact of this should just be 1. So I'm curious what will happen if we do dot size times a dot item size. We get just 1. So it was 1 byte for all of this, but the overhead for setting up a array is 112, I'm guessing, bytes. So we would expect that our total memory impact of null vector would be 112 plus 80, which I think is 192. So I'm just curious, again, if we get that. Yeah, look at that. So 112 is the overhead of setting up the NumPy array. 80 is the actual memory size specifically of the array. Weird details, but I think worth noting. Hopefully that kind of made sense, but I'll kind of leave it. I don't know, I'll leave both on the screen here. total memory, and this is memory size of just the array. Hopefully that kind of makes sense. How to get documentation of the NumPy add function from the command line. That's so interesting. We have to do a command line type thing here. np.add. I think we can do np.add.doc. I guess that's the doc string. Let's see. I mean, this gives us the docs. It's not really via the command line, though. I mean, using the command line, though, we could do something similar. All right, so going to our terminal, the equivalent would be Python. We want to activate our virtual environment. We type in Python, do import NumPy as np, and then we do np.add.doc, and then I guess print that. I mean, this is from the terminal, so I don't know if this is what it's looking for or if it's looking for something else. But I mean, this is the documentation for it. Luckily, that kind of just auto-populates in our terminal. So let's try a hint here. I guess we can't do the hint with having the print statement there. It's kind of confusing. np.info. I mean, I could also do, let's see, let's try to do it like that. np.info. And I think a key thing here is that there's multiple ways to do certain things. And we could honestly do probably np.add. And look, that gives us the documents as well. So I'm curious what the answer is here. Multiple ways to do the same thing. Oh, why did I do answer 3? Answer 5. Okay, so from the command line, you could do all of this in just one go. They give this because that's what you would need to do in your Jupyter notebook, but you also could actually do an exclamation point, Python -c, import NumPy as np, np.info, np.add. This will also work. So we see we get that. So exclamation point can also run terminal commands in addition to what they provided, which was this %run. So I'll leave that on the screen as well. And you could also do what we did here. All right, create a null vector of size 10, but the 5th value, which is 1. I mean, this is just repeating a similar process to what we did previously. So we could do nulls equals np.zeros, because that's apparently what it wants, size 10. And then the 5th value is 1. So now we need to just think about, are we talking about the 5th index or the 5th value, which is the 4th index? So we start with 0. Is the first index. So the 5th index is actually nulls 4 equals 1. And then if we printed nulls, we will see that 1, 2, 3, 4, 5th element is 1. The rest are zeros. I'm pretty happy with this solution. Let's see if that is what they say. Array 4, yep. And then I bet you if you see the answer, yep, exactly. Just what we did, we just had a different name. I guess nulls is maybe not the most descriptive name because we do actually add a 1. but I'm happy with this. All right, create a vector with values ranging from 10 to 49. This just uses a function that you should probably know. Easiest way to do this, you could obviously do like np.array and pass in a list, 10, 11, 12, 13, 14. That would be really frustrating though. So the better way to do it would be do np.arange. And I bet you if we look at the documentation for this, if you looked up the actual documentation for this, there's a start and a stop. I guess you can keep scrolling down. Oh God. np.arange. I'm struggling here. Yeah, return evenly spaced intervals within a given interval. It has a start value and a stop value and a step. So this is just like when you do like a list comprehension or use the for I in range type function with normal Python syntax. So we could do 10. And then if we want it to go to 49, we actually need to do a to 50 because this number is exclusive. And then our step is 1, but that's the default value. So we could just leave this blank. And we will call this like, I don't know, nums. And if we print nums, we will see that we get our vector with range, with numbers 10 to 49, not including 50. Reverse a vector. I mean, there's multiple ways to do this. There might be a reverse method, but I think the easiest is actually to just use a list or like a slicing syntax. Just do : which basically means all values, and then -1. So we look at this, we do see that it is reversed. And this is the same as doing like 0 to 50, -1. Oh, maybe not necessarily because it's going actually from 50 to 0. Yeah, that would be close to the same. It's kind of confusing if you actually put in values here. So my recommendation is if you just need all elements and you need it to go backwards, : -1. And I'll just call this reversed nums equals nums print reversed nums. Let's see what they have for a solution here. Hint 8. Yep, same thing here. And then if we actually look at the answer, 8. Same thing. Cool. Oh no, I deleted the whole cell. Command Z. Wanted to just delete this line. Create a 3x3 matrix with values ranging from 0 to 8. So this is very much similar to np.arange, but this time we want to actually pass in a shape. Is there a shape part here? I mean, there's two ways to do this. You could just use nump.arange and then reshape it. I don't know if I can do that just directly via the function. So I'm going to use two functions here. We got np.arange. We'll pass in 0 to 9. And then I'm just going to reshape this. Dot reshape. It'll pass it in as 3x3. So this will work. I do see that. Curious if they have a different solution. I'll just call this matrix. Print matrix. Yeah, I'm curious if they use a different solution or if they just do this. Answer 9. Yep, they did the same thing. And I guess I didn't need to do 0 to 9. If I just included 9, it would have known that it starts at 0 naturally. So I guess one good thing to know about that. Find indices of non-zero elements from 1 to 0, 0, 4, 0. Okay, this is going to be a numpy.where. So I'm going to call this like array equals np.array. I'm just going to pass in the values they give us, 0, 0, 4, 0. So we expect the indices to be, the returned list to be 0, 1, and then 2, 3, 4. 0, 1, and 4. So to get that, we can do a np.where, or actually, I think we can just do array.where. Oh, no, maybe not. Okay, np.where, and then we just want to do array, and we want it to be non-zero, so not equal to 0. And we could say indices equals np.where, print indices 0, 1, 4. That's what we expected, so that looks good. Just for the heck of it, let's look at what they put here. Oh, they did non-zero. So there's multiple ways to do this. Non-zero is another function. I didn't know that that was a built-in. np.where is a little bit more, I guess, universal of a function, but this might be, a bit optimized. Cool. Let's go to 11. 3x3 identity matrix. So an identity matrix, I believe it is, it's been a little while since I've done linear algebra, but I believe it is this, forget which way I believe it is this. One's on the diagonal. I'm guessing there's a built-in identity function. I should maybe just double check what an identity matrix is. This is kind of embarrassing, but it's been a little while since I've done a math class. Images. Okay, cool. I was correct. I just didn't know if the diagonal was the other way. So how do we do this in NumPy? Well, I can do like quote, 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 do a comment here, quote, quote, quote. So we know what we're working towards. And I could do something like np.identity. Oh, look at that. There is an identity function. And it's just n, which is going to be this is always in square matrices because it wouldn't make sense in other types of matrices because it's from one corner to the other corner. So identity 3 is going to be our identity matrix. So I'll just call this like I. And honestly, I guess if I was naming this in a software project, I would want to call it like identity matrix or something like that. Print identity. Can't spell. Identity. Look at that. Looks good. And let's just check what they did for their answer. Oh, why do I type in 3 there? Answer 11. Oh, there's another one just called E-Y-E. That's kind of confusing to me, but cool to know. Same exact thing, though. I bet you they are completely identical. I'm curious if it says anything about I here. I don't know, but another way to do it is np.i. Let's just confirm that works. Yeah. Autocomplete is definitely helpful because if you have a sense of what you think the function might be, you usually can start typing something like that and you'll usually see an autocomplete option. All right, create a 3x3x3 array with random values. To do random values in NumPy, you're going to want to do np.random. And then this gives you access to all sorts of random functions. So you have like randint, random, which is going to be 0 to 1, So it doesn't really matter what we do here. I might just do np.random.random, and then we need to pass in the size, which is going to be a tuple, which is 3 by 3 by 3. And I'll just call this randos equals np.random.random, and I'll print out randos. We see that 3 by 3, another 3 by 3, and a final 3 by 3. So that's a 3 by 3 by 3, a three-dimensional matrix here. Let's see what the solution says. Yeah, they're the same thing as us. Create a 10 by 10 array with random values, np.random.random, and we want it to be 10 by 10, and we want to find the minimum and maximum values. Maybe it makes sense for us to do like randint here. It doesn't change anything. Actually, this does change something because it's a different type of function. If we did randint, we would first need to pass in a low value and a high value, and then pass in the size. So if you see that, you see that. The nice thing about this, though, is that randints is that we know that the max should be around 50, and we know that the min should be around 0. I think you can probably also seed this. There might be some way to seed this. What a seed is in random values is like it sets the randomness kind of in stone. So even though you're getting these random arrays and whatnot, every time you repeat running the code, it stays the same. So it's good if you need reproducibility in something that you're running. But like if you needed that actual randomness in the wild, you'd want to remove the seed. So I think if I did something like np.random.seed, and I set it to like 42, when I generate this array, it's going to always be the same array. So let's now look at randints. You see how I keep running this, keeps having the 6 at the bottom and the 38 in the left. If I instead removed this line, now it completely is random. So that's what a seed does. If you need like reproducibility in like a test environment, and if we want to find the min and max, we can just do max. We get 49. And if I wanted the min, you just do .min, and we get 0. So that makes sense. I mean, this is going to change because we don't have a seed there, but this is what we need to do. Cool, let's go to 14. Create a random vector of size 30 and find the mean value. So we'll call this array 30 equals np.random.random 30. And if we want to get the mean value, we can just do array 30.mean. And we expect it to be around 0.5 always, because this is between 0 and 1 generating random values. So, and we see that when we run this, it is around that 0.5 with some, expected fluctuations. One thing that's cool, I guess it wouldn't be that useful in this case, but you can change the axis of this. So if I said axis equals 1, or I said axis equals 0, I guess it doesn't necessarily work in this. If I did a reshape to 10 by 3, and then I ran different axes, if we print out, and we'll probably see this in future problems, but basically then this could do the average just on columns or just on rows if we do 1. So this is the average just on the rows here. But we don't need to actually do that. We'll just use axis equals none and just get the single value. Or you could just, that's the default value, so you could also just do this. Cool. 15, we're cruising right along. Curious what the answer is here for 14. Yeah, exact same thing. 15, create a 2D array with 1 on the border and 0 inside. That's interesting. So it's looking for something like let's run this with quotes again. For 1, 0, 1, 1, 1, 1. Just looking for something like this. I mean, to make this universal, let's think. I mean, like the simplest thing that I would do is just do like np, like ones equals np.ones 3 by 3, and then I would know that we print out ones. We know that this is the 0th row, this is the first row if we're talking about indexing, and then this is the first position. So I could do something like ones, 1, comma 1, is it like this, equals 0, then print ones. It might be, okay. So this gives me first row and then first column in that. And I'm talking about first as in index 1. So that's one way to do it. I'm trying to think if you wanted to be more generic, you could make like a zeros matrix. If you wanted to be more generic, you do something like zeros. And this has to be like odd sized. I mean, I guess it depends on if it's even or like what I'm just saying is if this was just a 2 by 2, it doesn't make sense in this case. So we do need like one dimension to at least be odd. Equals 3, let's say. Size, and then you could do zeros equals like np.zeros size minus 2 size minus 2. You do some weird stuff here where then you have ones from, we got an index on both positions here. So ones from 1 to the length, or like, this is not perfect. That would give us 1 and 2. Yeah, that would be good. 1 length ones equals zeros. I think something like this would also work for a more generic solution. Oh no, it didn't quite work. And then if we change the size to 5, look at that. Changed it to 7. And this works because it's it's square. If we needed this to be a little bit more generic, you could do like ones.shape 0, I think, and ones.shape 1. Don't worry about the weeds here. I'm just like going a little over the top here. The solution we had to start with was totally fine. But I was just showing a little bit more sophisticated of a solution where like we had a dynamic variable. I am curious if I create a new cell, what is the answer here for 15? Hint 15. Okay, and that's actually doing it a little bit differently. That's a little bit easier than length ones, -1. This is also doing the same syntax saying go until 1 from the end. So that's another way to do it. And then the actual answer. Yeah, so they did a specific example. We just made a little bit more of a generic one. All right, 16. How to add a border filled with zeros around an existing array. So we have an array. Does it mean here that it's a one-dimensional array? So we're going to just give ourselves an array. We'll say that this is np.array 1, 2, 3. If we needed to add a border of zeros to that, then basically our dimensions is going to be 2 more in the x direction. So we need at least 5 elements in the x direction. And then because this is just an array, we need 3 elements in the y direction. So 3 rows, 5 columns. So np.zeros to make it generic, 3 rows, and then array, I guess length array, plus 2 columns. That's going to be our matrix, and then basically what we want to do is insert the array into that. So it's going to have to go down into the first entry, and then it's going to start from 1 to -1, and we're going to set it to array. So hopefully this indexing all kind of made sense. I can print out these individual elements so it is a little bit more clear. And we'll then print the final zeros. Okay, so we have our array. We have a bigger zeros array that we ultimately want to insert this into, and then we insert this in. I'm curious what the hint here for 16 is. Oh, np.pad, shoot. We just did a manual solution when there was a nice elegant solution. So I bet you the answer is a lot simpler. Yeah, okay. So this is a nice, more elegant solution. This also worked, but this was a little bit not the most, I guess, NumPy-like. But np.pad, 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 np.pad. Remember np.pad. Oh, and we did kind of do this. So this was kind of our solution. In a similar way. So there's no one right answer. It's always interesting to see other people's answers too. What happened here? Oh. What the heck? Did I screw something up? What is the result of the following expression? 0 times np.not a number, np.nan equals np.nan. Holy moly, I don't know. Can we just type this in, or am I supposed to know off the top of my head? Like, I would think that, but like, what? Am I doing it one at a time here? Or is it all in one go? These must be individual expressions, like they're bulleted. I feel like this should be called expressions, maybe. I would say 0 times np.nan would be just np.nan. So I'm going to just write down my answers, but you could always just actually type in these expressions. So first I'm going to guess. I think this is going to be np.nan. I think this next one is not a number equal to not a number. I just feel like this is going to be false just because like it's kind of like saying infinity is equal to infinity. It's like doesn't really make sense. I do think that this will evaluate to true. np.nan equals n. I kind of think that this will stay np.nan because it's not one set number. I feel like this will be false. Or is everything false maybe? Like everything 0? I would think that this should be definitely true. These are my final answers. Let's go ahead and run this stuff. So I'm just going to copy these lines, paste them in, and run. Everything is false. Well, I guess I need to print them individually. This last one's false? That's crazy. Oh, I could do definitely like a special thing in Visual Studio Code to add this print statement to all of these lines, but I forget how to do that. You can add multiple cursors somehow. Cursor. I might actually look this up. This is kind of cool. Add cursor to multiple lines VS Code. Ah, that's a lot of things. Okay, Command Shift down. I think that's Shift or Control, Command Alt. Okay, Command Option down. Okay, go back to Visual Studio Code. Command Option down. Oh, look at that. And I can do print. Then I can go to the end of all these lines. Oh no, this screwed it up. I was so close. I'll just add these manually. That was kind of cool. Are these all false? Okay, np.nan, that's what we thought for the first one. False, good. True, interesting. Or false, okay. I guess this is just weird to compare these two. So that makes sense that this is false. NAN, that's what we thought. True. I guess that kind of makes sense. And then this is false. I don't, oh, okay. Is the equals evaluated first? Like if we added parentheses around this, would it be true? That's weird. I find that very surprising, that last one. Well, this is the answer. So ignore what I wrote originally. All right, 18. Feel free to try this on your own and then pause when you want to see my solution. All right, so first we want to create a 5x5 matrix. So we could do matrix equals np.array 5x5. And then we want 1, 2, 3, 4 just below the diagonal. So let's just look at our matrix first. Oh, oops. I should have done something like np.ones or like np.randoms. Maybe zeros is better. Okay. And we want 1, 2, 3, 4 right below the diagonal. So I'm going to just think if there's anything easy we can do on a number front. So this is going to be we're going to have like array equals np.arange to 5. That gives us, oh, I guess 1 to 5. Okay, so now we have our two things. And basically, I think we want to do matrix and we're indexing at the same time. I'm trying to think if there's a neat, easy way to do this. Like, I feel like if we just did something like array equals array, would that make sense? Now, this one's like offset by 1. Let's see what happens if I run this. Like, that's close, right? But this one is offset by 1. So if we did array minus 1, I think that would shift it. So just let's look at this again. Print array, we get 1, 2, 3, 4. If we do print array minus 1, that's going to broadcast it. I think that's the term that you say. So that's going to be 0, 1, 2, 3, as we see there. So if we do array, which is 1, 2, 3, 4, that gives us row with index 1, row with index 2, row with index 3, row with index 4. And then on the flip side, it gives us column 0, column 1, column 2, column 3, and then we set that to our actual array. So I think that this is a pretty good solution. Pretty elegant. I'm curious what their solution is. So let's look up their hint. This is 18. np.diag. Oh, you can do an offset with a diagonal. So that's another way to approach this. And then, so maybe I can try this real quick with the hint. We could do matrix. Just comment this code out real quick. Do matrix np.diag. What is the documentation here? I think we can do matrix.diag, and then we can do an offset. Does this work? I'm not actually positive how they do it. Okay, it gives you the diagonal. Can get specific things from that. Can I do matrix.diag? I don't know. Interesting. I feel like you want to set like k equals -1 to get the specific diagonal. How do I set one though? I guess maybe I pass in matrix, and then I set it equal to array. I don't know. I'm going to leave my solution here. And let's see what their solution is. np.answer 18. z equals np.diag 1. Oh, this is so interesting. What does 1? That's just going to give us, that's the same as this. So it's giving us that. Oh, and it's saying that that's the -1 term of our overall matrix. That makes sense. That makes sense. It's like a reverse engineering thing. But I'm also happy with our solution, but I'll add this as a comment here. So like we could have, if we wanted to give our, in terms of our solution, we could do 1 through 5 here. And if we printed z, we would also get the same type of matrix. See that? That's cool. All right. Create a 8x8 matrix and fill it with a checkerboard pattern. This is pretty cool. So I think first we want to do like, let's do this zeros and ones. So I'll call this like checkerboard equals np.zeros 8x8. And then all we want to do is basically fill. So let's look at our checkerboard. We want to fill this one way, this one way, this one way, this one way. I'm trying to think, are those all even positions? Not quite, because this would be an odd position in that row. One thing you can do, which is cool, is like if we think of their overall index, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. We want 1, 3. I'm confused. Oh, it shifts every row. Okay, there's multiple ways we could do this. I was thinking about flattening it, but that doesn't actually quite work because it's not like all odds or evens are the ones here. It depends on the row. Can you do the absolute value of the position? So the 0th, even, if it's odd. This is a really like kind of quirky thing. We're on the 0th row, and there's probably a simpler solution. 0th row, I'm gonna use like the odd evenness of both of their dimensions added together. So 0th row, and let's say we wanted this one as a 1, 0th row, first index. So that's our odd positions, odd, 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 odd. And then on this one, we're in the first row, and this is the 0th index, so first row plus 0th column is also odd. So if we did like np.where the checkerboard dot shape dot sum, this is like a little bit quirky, mod 2, so that's divided by 2, equals 1. Then we want it to be 1. Otherwise, we want to leave our checkerboard as is. Tuple object is not callable. Can I do shape? Okay. I think it might be this. I'll double check in a sec. Oh, shoot. I need to do like each index. Checkerboard. Like this is what I want to do, but how do I make this? I could make a array of their indices. This seems like I'm overcomplicating it though. I could just run two commands. I could do from on the rows side, we're going to do, I'm going to add ones to the rows and then that are odd and then ones to the rows that are even. So we can do something like np.checkerboard so I would be stepping over all rows, looking at all columns by 2. Then every other column, starting with 1 to the end by 1. We're going to set this to 1. And then starting on the other rows, so starting with 1, going by 2. Does this work? 2. And then the even spots here. So I guess this is probably every other. Like this, we want to set this to 1. And now if we look at our checkerboard, look at that. Okay, that wasn't too hard. I don't know why I was overcomplicating it. So this is getting every other row, and it's setting the odd spots to 1. This is getting every other row, starting with the second row, first index, and setting every even spot to 1. Let's look up the answer here. Yeah, they did exactly what we did. They specifically specified ints. That's not super important though. Okay, consider a 6, 7, 8 shape array. What is the index XYZ of the 100th element? So that means each row is a 7 by 8 array. So the first row, 7 times 8 is 56. So it's 56 elements. It's not going to be in the first row. It's going to be in, or not the 0th row. It's going to be in the first row because if every row is 56 elements, then the second row, first index, is going to include the 100th element because there's going to be 112 elements in those first 2 rows of matrices. 1, and then we got to think by the row and column of that. So we have in the second thing, and then this has, if we look at each 7 by 8, that means 7 rows, 8 columns. So we're already 56 elements through, and we're going to be like a little bit off by 1 here, I feel like, with how we think about this in our head. But 56 elements through, and then we're going to have 7 rows in this thing with 8 columns. So we need to get to the 44th spot. So the 44th spot is going to happen. First 5 rows have 40 elements. The 6th row is going to contain that 100th element, and it's going to be the 4th spot in that 5th row. I might be off by 1 here. So 5, and then the 4th spot. So this is 56, this is 40, we're at 96, and then plus 4 is going to be the third element, I believe, the fourth spot. I think it's going to be, we can try this, np.a range from 1 to whatever, 1 to 6 times 7 times 8 dot reshape 6, 7, 8. Curious what that would give us. Oh, we're so close. This needs to be 0. Okay. And so if we then get the 153 out of that, should be 99. Look at that, it's 99. So I'm going to say the answer is 153. Final answer, 20. Okay, well, it's telling me that this is the answer. 153. Cool. So we got it. I didn't know how to, I guess, I don't know how this is. Oh, that's kind of cool. So this would give you the index if you need the 99th spot from a 6 by 7 by 8. It will actually tell you the index. I had to do it with manual mental calculations in my brain. So either way works. Okay, create a checkerboard 8 by 8 matrix using the tile function. So real quick, let's look at what the tile function does. I'm going to do an array of 2 elements, or maybe we'll do like 3 elements. 0, 1, 2. If we tile this, I think we have to do np.tile. I don't think you can do array.tile. Yeah, np.tile. If we did it with array, and then let's say like 5 times. God, what happened? Oh, array. We see that it goes 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So to make a checkerboard, I would say we should just do 0, 1. And then 8 by 8 is going to be 64 elements. So if we do this 32 times, watch what it gives us. And then if we just reshape this to an 8 by 8, that should give us a checkerboard. Oh, not quite a checkerboard. How do we fix this off by 1 issue here? Is there any other functions in this tile? Like the cheating way, let's just see what other options we have with our np.tile. I think it's just these 2 functions. Yeah, just 2 things. What we could do, though, is np.tile for, like, I'll call this odd rows, odd row, even row would be equal to np.tile. We could even use the same array and just do it in reverse, which is this, by 4. And then we could stack the 2 on top of each other 4 times. So like, we have the odd row. Then the even row is going to be the ones start. And now we just need to like combine those. Can I do this? Odd row, even row. I could honestly do np.array, odd row, even row, and do this 4 times, right? Dot reshape 8 by 8. How does this look? Oh no, it's the same thing. So, is there an axis or something I can add this to? Because it's adding them. Maybe if I surround it with another parenthesis here to like make them more together. That's strange. I mean, the thing that's frustrating is I could do np.repeat 4 times and then reshape, and this would work. Maybe not. What am I missing here? So that's adding them all to this. Could I reshape this in a different way? Like need to concat them. So if I did like plus, I just don't know what functions I want to use and what not. What happens if I reshape this? That works. I don't know. Okay. The issue is they were separated before, I just, when it says using the tile function, I don't know if that means like don't use any other functions. So the H stack like horizontally attaches these things. So if we look at just this printed out, we see we get like this looking thing, and then repeating that like does what we need. We repeat it 4 times or tile it 4 times and then reshape it, and that makes sense why it works. I just don't know if H stack is acceptable in this case, so I guess we'll just look at the answer. We did use tile. Oh, interesting. Oh, you can tile with a shape here. 4 by 4, so it can go in both directions. Interesting. Okay. Good to know. So this is a matrix. It's, tiling those. Okay, that definitely makes sense. You live and learn. Normalize a 5 by 5 random matrix. So normalizing a matrix, what does that mean? It means like get everything to add up to 1, I believe, on rows or columns. Let's just double check that. What does normalizing a matrix mean? Yeah, scaling its values to a range of 0 to 1. This is done by dividing each element of the matrix. Yeah, I haven't done linear algebra in a while. And then you can go down a rabbit hole of what is a determinant. Okay, so it's normalizing matrix. Okay, this is how you calculate the determinant. That was a little bit of an aside. We're getting really into linear algebra here, so if this doesn't make sense, look up linear algebra. But let's take a random matrix. So and I'll make this 0 to 10 and a 5 by 5. a equal, or
Good.
call this mat equals this. We'll give this a random seed. We got mat here. Okay, and if I run this again, we can see that it doesn't ever change. Okay, so getting the, normalizing it, I bet you there might be like a norm, np.norm. I guess not, but we could do mat.determinate or np.determ. How do we get the determinant of, I'm not gonna like do the, like there's definitely a mathematical process here. I really would think that there would be like a determinant function. Is A the determinant? This is, I'm just gonna have to Google determinant in NumPy. Okay, there's a linear algebra dot determine. Good to know. But yeah, there's also a linear algebra dot norm function. We're learning. np dot linear algebra dot norm. Yeah, we can pass in matrix here. Matrix norm. Matrix. Okay, I guess I'm going to just do determinant of that, and then we'll just do mat divided by that. I guess this is the normalized matrix. This is element-wise division by the determinant. I would think that there would be a one-liner to do this, but let's just look at the hint. I mean, if I needed to do x minus mean, that'd be mat minus mat dot mean, all divided by mat dot standard deviation. I would want to make this in parentheses. I don't know if that was the same exact value. We'll print this too, just to check. Okay, not quite the same value. Okay, so I guess this is how you normalize it. Let's look at the answer. Man, I really need to review. I guess I just don't use the linear algebra a ton these days. Okay, now we got it right. You can also call, mean and call standard deviation, so that's just a slightly different way to do it. Create a custom data type that describes a color as 4 unsigned bytes. Huh. And I don't know how to do this. So for unsigned bytes is going to be uint 4.
Yep. Right.
I don't know how to make this though. I don't know how to do this one, 23. Sorry, gang, I'm going to just have to take the hint. And, you know, this is something I definitely feel like would Google. What happens? Maybe I do like RGBA equals np.datatype. The U4 would be unsigned 4 bytes. And it like seemed like that was an autocomplete option. This is my final answer. Let's see what the answer is to 23. I never had to, like, I've never worried so much about having it, like, performance being so, I guess maybe I don't want to say never, but I feel like I find it very rare in my day-to-day. I'm not, you know, I want things to be fast, but I don't need to be so performance optimized where literally I'm only using 4 bytes to represent our, like, RGBA. Like if I use a little bit of extra bytes, totally fine. And just to make this clear, like each byte is 8 bits, all of 0 or 1s. So it's basically just saying like you're representing the RGBA. What does the A in RGBA stand for? Red, green, blue. What does A in RGBA mean? Stands for alpha. So that's the transparency / opaqueness. So it's basically saying that we're representing RGBA in this format, which makes sense because you don't really need any more than this. Each byte, 2 to the 8th, what's 2 to the 8th? And like, you know that RGBA is 0 to 256. I think 2 to the 8th is 256, yeah, okay. So that's why you're making a custom type like this. So I think that this is probably the solution. Let's see, answer 23. Oh, interesting. I don't know. This is not something that I've had to deal with, but I guess cool to know. 24, multiply a 5x3 matrix by a 3x2 matrix. Okay, one thing that's nice to know about matrix multiplication is that when we multiply them, we want to make sure that the middle values, so the 3 and the 3, are the same value, otherwise it doesn't work to multiply them. And then our resulting matrix will be the outer values, so it'll be 5x2. So we could do np dot, how about 1s of 5x3, and then call this A, B equals np.ones 3 by 2, and then C equals A times B. We can just do it like this. If we look at C, it's going to be I think we can actually do dot matrix multiply np dot matrix multiply A comma B. It's trying to do some weird other stuff. Now we look at C. Get 3, 3, 3, 3, 3, 3. And if we look at A and B real quick, I'll just do like one entry. Print A, print B. This is 3 by 5. So basically what we're doing is we're going this row and this column. So 1 times 1 plus 1 times 1 plus 1 times 1. Look up matrix multiplication if you're not familiar, but that equals 3. And then basically if we just repeat the process, so now this 1's with the second column, we get the next 3. We basically just repeat this process. That's how we ultimately get all the 3's. But all we really needed to know about was this line right here. If we look up hint 24, but you'll see, is there no hint for this one? Answer 24. There better be an answer. np dot. This is also, okay, they're saying do a dot product, but there's also just this matrix multiplication function. But these are the same. Curious. Difference between dot product Yeah, so dot product is just on a scalar value, but matrix multiplication is a bunch of dot products. So I'm happy with our solution here. Given an array, a 1D array, negate all elements which are between 3 and 8 in place. So I'm going to do dot array equals np dot random dot rand int, how about 0 to 15 with a size of, how about, I don't know, 20. So we got something that looks, maybe I'll just make it like 10 elements. Got something that looks like that. I will seed this just to keep it the same. This stays the same. Okay, so elements between 3 and 8 are negated. I think that's inclusive, so this would be negated, this is negated, this is negated, this is negated, this is negated, and that's not negated. So all we need to do is just do array. We can do multiple expressions in this, so we can do array is greater than or equal to 3, and array is less than or equal to 8. And in those conditional spots, we want to set the value equal to, oh, we just want to negate them. So I might use an np where here. I'll say negated array equals np.where, same conditions, array greater than or equal to 3, and array less than or equal to 3. When that is true, or less than or equal to 8. When that is true, we want it to be array dot, array times -1 basically. And when it's false, we just want it to be array. And look up the negated array. And so if we looked at these together, we see looks good. I'm trying to think if there's a better way to do this. Is there just like a... What does this do? It looks like that works as well. I'm curious if we could have done this without the np.where. What would happen if I just did array with this condition equals array dot. I don't know if that would work. I think we might have to do the np.where. Let's see the hint here. This is 25. Let's look at the answer. Times equals. That makes sense. np.where 1 works as well. This is weird. Range 5 minus 1. I feel like it probably errors out on the first one. I don't think you can -1 from a normal array, but this then makes a NumPy array. Minusing 1 is going to be -1. Okay, so I think the first one is an error. And then I think the second one, we get range 5 is going to be 0, 1, 2, 3, 4.
But
range 5, comma, -1. What does that do? I'm really confused here. What would a sum function? What would be the -1 axis? Oh, counts from last index to first index, so it's like reversed order. But that doesn't really change anything. So it just... So I still think the sum is just 3, 6, 10. I think it's going to be 10 on the second one. Okay, so this is what I think we're going to get. Oh, interesting. I guess this does... Oh, okay. I mean, we're not minusing 1. That's where I was getting tripped up. What does the normal sum function do? Now we have this import star in our NumPy. No. I might like restart a kernel here because I don't want all the... Right. If it restarted correctly, then I can't access NumPy. Okay, NumPy is not defined. That's what we want. Okay, I misread this one. It should be 9 and 10. Consider an integer vector z. Which of these expressions are illegal? This would raise all of the elements in z to some power of z. That would make sense. What does the shift do? Oh man. I think this is fine. I don't know what.
Yeah.
Call this z. Okay, my predictions are valid, legal. I'm going to say this is legal. I'm going to say this is illegal. I don't know why. I'm going to say this is legal. This is legal. I'm going to say this is... I think that these might be bitwise shifts here. So it's saying shift it, shift it. I think that this is also maybe legal. I don't know what this one does, but we'll find out. It's very interesting things. So start with running this. I guess I can't even run a simple one. All right, so let's just look at z real quick. Okay, that's an integer vector, I would say. Z to the power of z. Yeah. That's interesting. Oh, I guess I should seed this again so we know what we're talking about. Look at z. Okay. So 6 to the 6th power. 3 to the 3rd power is 927. So that's when we do this. We do see 27 there. That is legal. Let's see what happens when we do. We're going to print z out so we can see both it and the transformation. 2 z 2. I feel like that's just going to leave it as is. What did that do? Oh, these might be bitwise shifts. I'll figure this out. I'm like talking to myself right now, but maybe it's kind of interesting. I don't know. Like, what happens if I just do the first one here? I mean, it was a legal expression, so at least we were right. This seems like a... What does mean in NumPy? Bit shift operators, left and right. Oh, interesting. Okay, I'm gonna explain this. I'm gonna explain what's going on here. So if we bit shift by z, and this is our z, and we start with 2s, so basically, let's just say we have a byte. I'll start with just one value. But we have 2. Basically, what we're saying is we have 2s all along if we're shifting bitwise. a left, I would say this is a left shift by z. So this would be a 2 in binary, this would be a 2. If we're left shifting by 6 for this first one, this would be 1, this would be 2, 3, 4, 5, and then 6. So this is now 1, and this is a 0. Did I add too many values? And so this is now, let's think, this was the 1 shift, 2 shift, 3 shift, 4 shifts, 5 shifts, 6 shift. Okay, so now we have 2 to the 9th. What is 2 to the 9th? Or it would be a 6 shifted left 2. We'll find out. I think 2 to the 9th is definitely greater than 128. So 6 would have been 1, 2. Shift that 2. That would be that'd be 1, 2, 4, 8, 16 plus 32, 48. That's weird. Let's go back to that docs. Hopefully what I was showing kind of makes sense. I should be able to at least get an answer. Left shift 2 left shift by 6. 2 to the 6th is, okay, that would be 2 to the 7th. Where was I getting 2 to the 9th? Okay. Go back to that first example. We got 0 here. We shift it by 6, right? It looks like this. This is the 0th index, first index, second index, third index, fourth index, fifth index, sixth index, seventh index. This is 2 to the 1st, shifted by 6 is 2 to the 7th. I don't know where I'm screwing up exactly. 2 to the 1st, 2 to the 2nd, 3rd, 4th, 5th, 6th, 7th. Okay, 2 to the 7th. That gives us 128. If we then shifted 2 by 3, 1, we're going to replace this. 1, 2, 3. This gives us 1st, 2nd, 3rd, 4th, 5th. 2 to the 5th is 2 times 2 is 4. 3rd is 8. 4th is 16. 1st, 2nd, 3rd, 4th. Oh, 2 to the 4th is 16. Yeah, that checks out here. And then we can shift it the other way too, which is what we're doing here. Pardon that aside. I don't know if this note makes sense, but this is the first example. That's what I was trying to show. Okay, keep going. Is this legal? What does that even mean? I don't know what this one means. Operator in NumPy. You could also use like ChatGPT or something. There is no, why is it working? Did it maybe get added or something? So we said legal, legal, illegal, legal, legal, legal. This one should just be all falses. Let's just try these other ones first though. 1j times z. This is converting it into imaginary syntax, I believe. This is good stuff to probably like throw into ChatGPT, but that seems legal. Z divided by 1 divided by 1. That should give us just z. Yeah, it does. And this last one, z is less than z, which is greater than z. This should just be all falses. Oh, interesting. That one's not legal. Okay. I'm really curious about that one operator though. So I'm gonna pull in ChatGPT. That's so weird. Why did it not fail? I guess we can just look at the solution maybe. Does it not give us any answer? I'm so confused. Let's just skip to the 28. These are tough. I have no idea about this one. I feel like np.nan has type int, as type float. It strikes me as 0.0 for the last one, so. np.array divided by np.array. I feel like this will be like error. Floor divide by 0. Kind of feel like this one's going to be 0 and this one's going to be 0.0. Let's try. Print nan. Oh, okay, that makes sense. It's not going to error out. It's going to give you an nan. That makes sense. This might be an nan too, honestly, though. Oh, it does give us 0. I wonder why the floor divide gives you 0. Because if you divide by any number, 0 divided by 7, it's just going to be 0. I don't know what the deal is with that. I'd have to get into the little specifics there. Let's see what this gives us. Oh, I guess it's going to be an np array of 0.0. Yeah, so that makes sense. So this was nan. How to round away from 0 a float array. I think this would be ceiling or something. Like we want the ceiling. I'm going to take an array. Goes np.random.random. Make this like 5 number array. And if I do array.ceil or np.ceil of array, this should all be 1, or this will be all 1s here. And like you could do that for any, like if we did 5 times this, it'll be random values, but this would round away from 1 or round away from 0. Yeah, np.ceil is one of them. Let's see the solution that they give. Oh, okay, so it wants you to round away from 0 with absolute values as well. Okay, that makes sense. So use the ceiling or use the ceiling based on whether or not it's greater or less than 0. How to find common values between 2 arrays. So if we have np, there's a nice little function for this. So we're going to do np.a equals np. How about a range 0 to 10. This next one's going to be np.a range 5 to 10. So we'd expect the common values to be 5, 6, 7, 8, and 9. We can do a.intersect, or I guess we have to do np.intersect 1d, a comma b. And that gives us what we expect. So that was pretty straightforward. Let's see what they said for the solution though. Yeah, intersect 1d, cool. How to ignore all NumPy warnings not recommended. I think you're gonna use np.warning. What does that do? If I really needed to do this, what I would probably recommend, like if I was using my Jupyter notebook, I might do command I, ignore NumPy warnings. Just see if it auto-completes this. Set error, all equals ignore. I don't know if that's right. I guess it would ignore everything, but that's warning. So I wonder if there's a np.set. That's like just floating point errors. Like things like this, I wouldn't expect to know off the top of my head. I want to see the answer. Okay, it was what the GBT or GitHub Copilot recommended. I did Copilot. I have GitHub Copilot, like I pay for it, I guess, so that's why I'm able to use this chat. So I do command I to open it if you do have it. np. I guess I don't really want that though, because now we're going to be screwed. So I'm going to restart the kernel. And just keep that commented out. What is emath? Oh man. I'm guessing that's like imaginary math. So I think that this is going to give us an error. So I'm going to say that this is false, because the one's going to be an error and one's not. So I'm going to say, no, it's not. Let's see, I'm going to say false. np.false, cool. And I think it's because we do get this runtime warning. So this is an np.nan, but because I don't know what exactly emath is. Yeah, I think that this helps translate things. So if we look at what happens when we do this, so we'll say like val equals this. We look at val, we get a complex number, but when we just do np.sqrt -1, we're gonna get like an error. And if I did like type of this, it's just gonna be like, I guess it stays a float 64. It just can't represent this. So I feel like it's ultimately like an NaN, I would think. But the nice thing is the type of the val is this complex number. So emath helps, I guess, translate to the proper types that are more easy to work with. Get the dates of yesterday, today, and tomorrow, np dot. I guess we probably do np.datetime64. I bet you there's like a date time. I feel like I'm kind of going a little crazy, so I'm gonna get some like chocolate or something. I'm a man of class. I got this dark chocolate. This is gonna power me through at least another 20. Also, fun fact is like I probably will film. Maybe I'll film this over 2 days. Probably will wear the same shirt to like hope that no one notices, but I'm telling you guys this, so now you know. It's secret. Surprise, surprise. That was pretty good. That was quite good. I'm a fan of that chocolate. All right. Is there like a date library? I'm gonna just look up date times, like, because I would normally do like import date time dot like UTC now, I think. It'd be something like from date time import date time, and now there's probably a function date time dot UTC now. I guess that this is I'm guessing this means it's deprecated. Okay. Okay, it would just be dot now. Like I would do this, and then I would do like date time dot. I would do like a equals date time now. Then I would be, or like today equals date time now. Yesterday equals date time dot now dot. I think I could do datetime dot subtract. Oh, okay. So I do today, and then date and minus date time dot time delta. Is there a time delta function here? Time delta days equals 1. That would give me yesterday. Similarly, I would add for tomorrow. And if we printed all these things, print today, print yesterday, tomorrow is equal to today, plus time delta, days equals 1. And you can set this delta to have all sorts of information. This is a very useful function. Print tomorrow. Run that. So you know when I'm filming. See, see, see. And the print is nice because it nicely formats it for us. But that does all look right, but it's not asking us how to do it in date time library land. Asking us how to do it in NumPy, and I do not know date times in NumPy. So we are going to date times in NumPy. Get date time of today in NumPy. I wonder if this is just like to how would I know this? Let's just look at the documentation here. np.datetime64 I want to see like the values. Like how would I know anything about this? I would look up, I guess, like NumPy datetime64 docs. I'm really confused. Like, does this work? That's crazy. How would I know this? Where is this in the docs? I'm gonna Google this specifically. I'm just so confused. Like, NumPy. I don't know, but we learned something new. Somehow it's in there. I just feel like datetime, get today's date, NumPy. I'm so interested by this. I don't know. Well, interesting, but we can use this to our advantage. What if I did .doc here? Okay. Arrays, date, time for more information. I'm done looking at this. We know that we can do today. So we can do today equals np.datetime64 today. Yesterday equals np.datetime or equals today plus np.timeDelta. And then we can pass in 1 day. It seems like we could do. Just print today and print yesterday, which I guess I accidentally put as tomorrow. If it was yesterday, it should be minus. And we need to know all the codes here, but I can imagine, like, you know, this is months. So if we added 1 month or subtracted 1 month, this would be 930. But maybe it's lowercase m. Or 1 minute, maybe. What is... We could definitely look up documentation here. Is there a go to document? Arrays date time. Datetime units. Here we go. Month is M, capital M. Week is W. M is minute. Lowercase. Okay. So we should have been able to did a time delta like this with a capital M, right? And then printed yesterday. Oh, it was NP. I don't know. I don't know what the deal is here. Okay, well, this would be our results, but I'm curious to see the answer here. This would be answer 33. Yeah, that worked. Okay, I don't know. I just don't love this. I feel like I would do something more similar to this if I was to do this in the wild. Yeah, it seems weird to me a little bit. Not like super friendly. I feel like Pandas has simplified that enough. How to get all dates corresponding to the month of July 2016. I feel like we're going to do something like July 2016 equals np.datetime64 Let's look at the docs again here. If we could do something like this. And if we did 2016 and then July, I always forget these dang dates. July is January, February, March, April, May, June, July, 07, right? What does July 2016 look like? Yeah, I mean, I could very easily, like, 30 days have September, April, June, and November, all the rest of 31. So I could very easily, like, I could very easily do, like, I feel like this is super messy. You could do something really ugly like this. That doesn't work. This is like 0 padded. This is gross. I need a hint. I need a hint. I'm tired. I need chocolate. Oh, wow. I could probably do something like np.a range. This value. Then, I don't know, what oh man, I could do 0, 1 as the start. Then 31 as the stop. That's like, I guess the stop would actually be 8, 0, 1. It'd be August 1st because you want it to be exclusive. Look at that. That's cool. Didn't know that. Now we do. Cool, cool. Let's see what the solution says. Oh, okay, cool. That's pretty neat. You learn something new every day. Oh my gosh. I need more chocolate. I'm crushing an energy drink right now too. Wired. Back's starting to hurt a little bit. Oh no, the chocolate. Ah. I'm getting chocolate on my desk. I wonder. All right, I need to burn off these chocolate bars. I don't think you can see me though. If I do push-ups, can you see? Kinda. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, 20 push-ups. I earned more chocolate, I swear. God. Gosh. All right, we're ready to go. We're fired up. All right. I think this is with matrices. How to compute a plus b times a I'm confused. I'm confused by this one. How to compute a plus b times... Am I missing something here? I'm confused. Like, is that fine? Then this would all be in place. I'm not copying anything. I'm so confused by this one. I guess though, maybe A would have to be the same. Like if I printed out just A, it shouldn't still be 1, 2, 3, 4. If I did np.add. I guess I do false here or something. Okay, so the output needs to be stored like it needs to be stored in a certain place. I can't store it in A because we need A afterwards, so we could store it in B. I wonder, do I need to like surround it in quotes? Oh, yeah, we need to make sure order of operations are as held np. Negative A. I think I can just do this. 2. And the multiply is ultimately, I think this can be stored in A. Like, we have to make sure it's, okay, so this is done first, stored in B. Then this is done, which doesn't depend on B, so it's stored in A. And then we're multiplying B and A. And so the output of that then can be stored in A. We'll just make this a data type. We'll just float 64. Probably need to make this float 64 as well. Look at that. I believe that that's good. Let's see the answer. So it's basically like we need to just use the memory we've already allocated, and that's what we're doing here. And because we only have 2 arrays to work with, we basically have to be smart with our order of operations and then copy our data in only when we're done with that output. Because this one still depends on A later on, we first save it to B. We'll look at the answer though real quick. np add, yep, output B, np divide, output A, np multiply, output A. So we just did it in one line. They separated it, but cool to see. Oh, the negative, I wonder if that matters. So I guess technically this should have been np negative. Okay, this is really if you're caring about every bit of memory. I feel like we are living a lucky era where this doesn't matter as much. Extract the integer part of a random array of positive numbers using 4 different methods. So I think what I'll do to, oh, we got to just extract the integer part. So like if we have 5.5, what I'm going to do is np.sqrt np.random.seed just to work with something. And then I'm going to do np.random.random, do size 10, let's say, but we'll multiply it by 5. Call this array. And then if we look at our array, okay. So we want to get just the integer part of this. So like 4 in this case, 2 in this case, 4 in this case. So the first way I think of doing it is we do array floor divide by 1, right? Because if you floor divide by 1, that will just give you the value. Anything divided by 1 is still the value, but the floor divide gives you just the lower bound. So it gives you the integer part, right? 4, 2, 4, 3, 3. Cool, that looks good. We could also do, and I'll just print these. So floor divide is one way to do it. We could also do this, the floor, print array dot floor, or I could do np dot floor of array. And then we get that same thing. That's 2 methods. So method 1. 4 methods is a lot of methods. Method 2. Method 3. Method 3 will do this, plus 1, minus 1. Technically, it's a different way, but I think that would be a little bit cheating. Plus 1, minus 1. Watch and learn. Look at that. All right, we will not do it that way, though. I'm so clever. All right, what else could we do? I mean, you could do the ceiling and then minus 1. I don't know if that counts. np.seal array minus 1. That would give us the same. I think that's like a valid enough method. I'm trying to think if there's another good way here. I mean, what happens if we just cast it to a different data type, I wonder? If we cast it to integers, array.cast, or what happens if I do this? As type int 64, or int 8 honestly is fine. That's another way. I'm pretty pumped about that. That's kind of a cool, unique way to do it as well. That's pretty good. I'm happy with that. I'm trying to think if there's anything else, because we're just I'm pretty happy with that. What would be the solution here? Answer 36. Floor, we did that. As type, we did that. Divide, we did that. Z minus Z mod 1. I'm trying to think how that works. Z mod 1. I guess array mod 1 would just leave the remainder. Okay, that makes sense. That just leaves the remainder of the array if you're dividing by 1. So if you subtract that from the original, that makes sense. So I feel like my ceiling solution was kind of cheating, but I wonder what the truncate method here does. np.trunc. Okay, so it's closer to 0 than x is, so it always goes downwards. I mean, this is just a range 5, and then we just do np.repeat. I might have to broadcast this too. I could do the transpose. So the transpose is like, if I go back to the original, is flipping the x and y coordinates. So if this is row 0, column 0, row 0, column 1, then when you transpose it, this becomes column 0, row 1. So that's why this transpose works. I'm trying to think if there's any other ways. I mean, couldn't I just tile it too? Yeah, tiling works as well. Let's see what this doesn't seem that hard. Oh, I guess then I could use this could be done. Why is it 5 by 1? But there's different ways you can play around with the tile function. It doesn't say anything about not broadcasting though, so I'm fine with what we left. Consider a generator function that generates 10 integers and use it to build an array. I mean, this is just what I've already kind of done. Zero to 100, and this build 10. I'm fine with that. I'm wondering what the answer here is. Oh, they actually wanted a generator. Okay, well, that's good to know. Create a vector of size 10. With values ranging from 0 to 1, both excluded. I think that this is just np.random.random. I guess 0 can be included in this. What is random sample? How can we exclude 0? I mean, 0 is never going to be actually included with random.random. I feel like maybe this is a wording issue. Like, even though 0 is included that set. I don't know how you do both excluded. There must be like another function that is a hard cutoff. So I don't know if people understand the issue that I'm seeing. It's such a minor issue. When I do random.random, this specifically half open interval, that 0 means inclusive 0.0. Oh, okay. We could do a trace or something like that. np.lin space zero, 1, 5. I mean, I can do something like this, but I don't know what they want me to do for excluded here. This is just like up to my interpretation. I don't know. I'm gonna I also would do the random stuff, but I'm not sure what they're looking for. What is the hint here? Okay, I did lin space. I'm curious if my answer is acceptable. They need to be excluded, so I did values close. What is the answer? There's an endpoint equals false. Interesting. 0, 1. What does endpoint do? That's crazy. And so it doesn't include, I don't know, this is a weird one. I feel like this is very niche. So it's not letting me create a random vector of size 10 and sort it. Random.random a equals np.random.random 10, and we're going to do, is there just an a.sort? Yeah. Oh, np.sort. np.sort a. That looks good to me. I could probably do this in place too. Like if I looked at does np.sort do it in place? No, it does not. It does make a copy. Is there an in place? How does sum a small array faster than np? All right, how to sum a small array faster than np.sum? A.sum. This is weird. Maybe cumulative sum? I mean, I could just do a.sum. I mean, I suppose that would be faster. Maybe a.cum sum. Yeah, I don't think that would be faster. I mean, probably indexing it if you know each index. What is a hint here? np.add.reduce. I want a solution. Or maybe let's look at the documentation there. np.add. Yeah, I feel like you really have to know the weeds to know that this is going to be faster for small arrays. That's unfortunately not something I knew. So the solution would be I don't know why that's faster. You probably could Google and like there might be discussion threads on this GitHub repo. All right, consider two random arrays A and B. Check if they are equal. All right, so let's just make two equal arrays. So if we just start by doing A equals B, what happens? So it's true, 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 because it's going element-wise. I think we can do a.equals or np.equal a comma b. Same thing. If we said axes, is there an axes column here? What we can do, what I do know as a solution is you can do something like a equals b. I think that's equal to np.equal. And then you can do np.all. That should give you a true or false. And if you really wanted to convert it, you could do something like bool. And so if we change this to like an 8, false. Change this to a 4.0. It should be still true. So np.all checks that all of those values are equal. Curious what the solution says though. All close. Here's what happens if I do np.array equal. Okay, so I guess this is similar, but it's probably something along what we're doing here. Let's see what the solution says. This is cool. I wonder how all close works. Relative tolerance and absolute tolerance. It's pretty cool. So if we had something like np.all_close AB, it's going to be true by default. If I change this to 3.0, it's not going to be true. But if I said absolute tolerance is equal to 2, it's going to be true. Then if I change this to like 8, it's going to be false. That's cool. It's a useful function. Make an array immutable. Immutable array. So immutable means you can't change it at all. Read only. Lights, turn on. So np.array, I'm guessing there's a parameter here, 1, 2, 3, and then I'm guessing there's like a special type of array. Interesting. I'm going to do a little co-pilot chat. Create an immutable array in NumPy. I would never have known that without looking it up, but good to know. So now if I try to do immutable array 0 equals 1, we probably should see like an error or something. Yeah, that's cool. Dot flags dot writable. Interesting. So let's see, answer 43. And you know, I am using Copilot Chat sometimes. I think that like with this type of thing, there's certain things you can kind of piece together and figure out logically, but like something like this, you either know it or you don't. It's hard to like just get to it. So you're gonna have to look this up. So Copilot Chat is kind of my shorthand for looking it up. And look, that does show the same thing. A random 10 by 2 matrix representing Cartesian coordinates. So we could do something like random.rand int So if you think about Cartesian coordinates to polar coordinates give you a theta and a radius. Cartesian is like your classic xy. This is another thing in math that, you know, it's been a little while, but we can start with at least our matrix. I'm going to see if I can piece together this. Okay, so this is our coordinates. So the way we need to change our coordinates is we need to create a new array. The radius is going to be Pythagorean theorem. So, I mean, I don't know how the easiest way I can like show this. It's like we have this axis, right? So Cartesian coordinates is xy. So like, you know, you're going, this is so hard to do while my hands are up. You know, I don't know. This is not working either. Let me just type on the screen. Why does it keep copying that when I try to do 3 quotes? So we got this little axes. Okay, so that's our axes. So we need to figure out, like, we're given points right now, so like a point right here, and that would be like x equals, I don't know, 3, y equals 2. But now we want to find the radius, so I'm kind of trying to draw a radius with my mouse cursor. So that would be, you know, 1 unit squared plus the other's square root of that. So coordinate 1 would be, I think there's probably like a magnitude. think we do np.linear algebra magnitude. How would I get magnitude? Would that be the determinant of the... Okay, I want to get a 3, 4, 5 triangle here real quick. Does this give me 5? You can't do determinant there. Magnitude.
Sure.
Then to get the angle, we have the x and the y, so it's going to be, is there a math package? np.math, np.math, maybe emath, I don't know. We're going to have to use some SOHCAHTOA here. So, two things going on. Sine, we have the x and the y. The angle we need is opposite over adjacent. So tan theta equals opposite is our y over x. So arc tan y over x equals theta. Hopefully that kind of makes sense. And the other value is just x squared plus y squared, and then the square root of that. Equals r. So how do we convert these? np.power Oh man, I'm tired. All right, so magnitude. I feel this is like a list comprehension, but I feel like that's not NumPy-esque. So like if I wanted to just get the arctan thing, it looked like I could do numpy.emath.arctan. No, is it? It's not arctan. What is arctan versus tan -1? Are inverse tan and arctan the same? Okay. Okay, so we were good right here. Should just be one value. Okay, we're getting there. np.sqrt, np.sum. This would be axes equals 1 or something like that. Okay. Does this make sense? Okay, it's this. Okay, that is the R's. And then how do I get the arctans? np.divide. I mean, this could be like np.divide. The first elements should be iterate over each row, grab the zeros for everything, divided by array 1. Wouldn't that work? Grab rows. You want to grab every row. Okay, sorry. You get every row this way, and then you grab the 0th element. Get to every row this way and grab the first element. And then I could just do this. Okay, we're good. Is that y over x though? This should be row is the first. Is the row the first one? Row is, that's x, y. Oh. X comma y. So y is second. This is first. Okay. So that is y over x, and then we want to do np.arctan of this. And then we want to do an np array of p.concat r. This is our r. This is our theta. R equals theta equals I screwed something up. Okay. And then new polar chords equals R something like this. Print polar chords. Not quite there. I want to do axes. Maybe I do H stack. I want to do piecewise. It's like a zip. I don't know. Is there an np.zip? Like in Python, I feel like I do r theta. I could like do a NumPy array of this. I think it's zip, right? Zip R array with theta array in NumPy. Column stack. Oh, that makes sense. That was silly. I'm just getting tired. That looks good. This seems, that's R, that's theta. I wonder if there's a better way to do this. All right, hint 44. What is the difference between arctan and arctan2? But I think that we probably got it. Let's see the answer of 44. Random, x comma y. This is our y, right? Y. This is our x comma y, np.square root. Okay, so they just did a little bit more, that makes sense. Makes sense to do it like this, but it's the same thing. We did np.sum after that. Cool. Oh, they got it in polar coordinates. They didn't zip it back together though. So we took it even a step further with this column stack. All right. Create a random vector of size 10 and replace the maximum value by 0. Okay. Array equals np.array, or np, I don't know, random.rand int I'm going to just do np.ones size 10. I'm going to put a random 100 in there. Print array. Okay, so how do we replace the maximum value by 0? But we need to do it in a dynamic way. Array.argmax. What happens if I just run this? Okay, 0, 1, 2, 3, 4, 5. So then if I do array an index array.argmax equals 0, what happens to array? Look at that. That's pretty good. What happens though if I have multiple 100s? So that's so you could do a two-step equation here too. If you did, so this works for one single value, so it replaces the 2 in this case. If you wanted to replace multiple, you could do something like max equals array.max, np.array equals np.where, array equals max, where that happens, where that's true, 0, otherwise keep array. Now if we look at array, both of those spots are replaced with 0. So 2 ways to do it. If only one instance. And you could even make this a one-liner and do array.max. If multiple equal max values. I'm curious what their solution is though. $45. Yeah, so they use the first solution. What does this even mean? Create a structured array with x and y coordinates covering the 0 to 1. Okay, so it just wants like a bunch of random values between 0 and 1. So I would say this is just like a random dot random and if you wanted xy coordinates, this is size. I would do something like 100 by 2. And this gives you tons of coordinates to work with. What does the answer say? Or hint even. What is mesh grid? Let's just look at the answer. I don't know if I understand this right. Like this would also kind of work. I don't know if it wants like evenly spaced things. So I guess it wanted evenly spaced things. What is the mesh grid? What does Z look like? Interesting. Given two arrays x and I, construct a Cauchy matrix such that Cij equals xi minus y. So we got an array. We got x equals np.array, let's say 1, 2, 3, 4. Y equals np.array. We don't want this to be divided by 0. Eight, 9, 10, 11. We won't run into any divided by 0 errors there, but maybe we make this just two-dimensional. Okay, so this then has a dimension of i's are corresponding to rows, or I guess x would be because we're going to have a 2 by 4 construct. Basically, our matrix C then is equal to I'm going to just look up Cauchy, however you pronounce that matrix. Just want to understand the dimensions here. So n by n. So x0 would be 1, x1 is 2. I feel like I need to use 2 for loops for this. Equals length x, length y. Let's just print out C real quick. I feel like it's the other way, right? I feel like x should be feel like it's going to look like this. For I in range X, for J in range Y. This is like very not NumPy though. C, I, J equals 1 divided by X, I minus Y, J. That's capital. Now look at C. Is there a better way to do this? Only what the heck, dude? Index 2 is out of bounds for. We just saw that that was right. So this row, what happens if I do J comma I? Oh, okay. Because there's only 2 rows. There's 4 columns. That makes sense. Is there a better way to do this? I don't know. I'm happy enough with this. Let's see the hint. np.subtract outer. Holy moly. I am hitting a wall. I'm not doing these well, huh? Subtract outer. Why is it giving it the determinant? I don't know. All right, I think I am. Okay, I think we can do this. We can do this. Minimum and maximum reps. Is there a I'm cheating on this one.
we're using a GitHub Copilot, did Command I. That's pretty cool. It's not fair how good some of these AI tools are. That just worked so quickly. How to print all of the values in array? np.array. It can't just do print A. Like what happens if I do A range 10,000? A.4. I mean, I could very easily do a for loop over it. I could also do list A. That gives me everything. I'm happy with that solution. If there was to scroll through this, it would give me everything. Hint 49. Okay, so I guess this is like a more generic solution. There's probably some way to like print, like let a print show more items by default. Okay, so threshold would be 1,000, but if we set that to a higher, you can also do sys.max size. Cool, so print out the documentation. I didn't really understand this one. How to find the closest value to a given scalar in a vector. I mean, if you subtracted that, okay, let's think. You would want to take the absolute value. So we have an array, np.random rand ints, how about 0 to 100, 100 values. If we have a scalar that's equal to 5, if we, and maybe we made it like negative 100 to, but it doesn't even matter. Basically, you want to take the absolute value difference. So you do 5, if you're minusing things from the array, .25. We should expect like 5 will probably be the closest. But if we subtract scalar minus array, okay, we get all the values. We want to take the absolute value of that. And then we want to take the floor. Or argmin. And then we would index the array by argmin.
Yeah.
Does that make sense? It's 5 in that case. If I had made it 5.75, we expect probably like a 6. But I feel like we ran it enough. We might get a case where, yeah, it's like a 7 or a 4. Cool. So we have to do the absolute value because it could be, yeah, we want the absolute value's distance to be the smallest. Hint 50. Yeah, argmin works. Let's see what the answer is. Absolute value z minus v argmin. We did the same thing. They called dot argmin. We did np.argmin. And then we indexed it like that. So we're good. All right, gang. I'm pretty tired, not gonna lie. We've done 50 problems, and I feel like it's been, I don't know, like close to 5 hours. I don't know when all is said and done with when I cut out the, you know, the random parts of the clips where I was just like frozen. Probably around 5 hours. We're gonna go with that. I think just so I can get content out more quickly, I'm gonna say we're done with this part. We did 50 of the 100, and I will release a part 2 either next Saturday or the following Saturday, where we do the remaining 100. And I know that, I mean, they have the relative difficulties in these star ratings, so I know that it's only going to get harder with a lot of these. So I think that for sanity and for getting good content out when I'm fresh and whatnot, we will plan to do the remaining 50 problems in a part 2. If you enjoyed this part 1, throw it a thumbs up. If I should tweak things for part 2, let me know. Happy to do that. Let me know in the comments. When part 2 is up, I'll make sure to like pop it up at the end here. Subscribe if you haven't. Be quiet, phone. Yeah, dude, honestly, like that's a lot of staring at code. But it was fun. It was fun. We had a lot of fun here. We had tons and tons of fun. Python is cool. I'm still sane. We're still sane. All right. I'm crazy. All right, just a little crazy. All right, we're gonna try that again. Thank you all for watching. Hope you enjoyed this first 50 problems. If you did, throw this video a thumbs up. Subscribe to the channel if you haven't already. Let me know in the comments ideas for future videos. Part 2 coming out fairly soon. Maybe I even make it a part 3. I think that we can squeeze the next 50 problems in a part 2. So I'll make it a part 2. Yeah. Till next time, everyone. Peace out.